Okay guys, just want to look at this leaving cert question based on the water crystallization in washing soda or sodium carbonate. So the whole experiment on this is calculating the amount of water that has been absorbed by the sodium carbonate, and depending on different amounts of water can be absorbed by the washing soda crystals. So the first number of parts in this question are pretty straightforward, and they're like your typical titration type questions. And then even the first part is part E here. It's quite similar to a normal titration question that we come across, and it's in the part F where you're calculating the X and the percentage of water crystallization. That can be tricky, especially with this particular one. You'll see it's worth 9 marks as well, so this can be one of the more tricky calculations. There are a few ones like maybe the iron tablet as well. We could do it further on. A few of them just have little quirky bits in the mathematical parts, but this bit here should always remain pretty consistent. Okay, so we'll set up our titration as we always do for the calculation. So we're going to look at the HCl and our base then, which is sodium carbonate. And then from that then we will set this up with our V1, M1, N1. That's the volume of the acid, the molarity of the acid, or the number of moles of the acid. And here V2, M2, N2. Now they could be VA, MA, NA, and VB, MB, NB, same thing. So you then need to go into your question and find the important bits of information. So we want to find as much as we can. So read through your question. Batch of washing soda crystals had some loss of water crystallization with positive efflorescence. Chemistry is required to determine the percentage of water crystallization in the crystals, the value of X. So no numbers there so far. Then we have a mass of our washing soda crystals, so 2.5 grams. That won't come into play yet. And the sample was dissolved in 250 centimeters cubed, and that's important as well. So with 2.5 grams and 250 centimeters cubed, remember everything we will work out will be in moles per litre, so everything we have will be a quarter of that. A number of 25 centimeter cubed portions of this solution. So this solution is the sodium carbonate that was made up. So that means our volume of sodium carbonate is 25 centimeters cubed. Then we titrated that against 0.1 molar hydrochloric acid. So that is the molarity or the strength of the hydrochloric acid. So there's the hydrochloric acid. So it's 0.1 molar. And we're told that the mean volume of the hydrochloric acid solution required to reach the point was 21.6 centimeters cubed. So they give us the mean straight away. Remember, sometimes they might give you the titration values. So they might say the first titer, the rough titer was 24, and then the two accurate ones or whatever. So what you do is you disregard the rough and you take your two accurates and get the average of those two. Anything else then? So the molarity of this stuff we don't know. Okay, and then for our N1 and N2, that's the number of moles, and that relates to this. What is the ratio within which HCl and Na2CO3 react? So for every 2 moles of HCl, you have 1 mole of Na2CO3. Okay, so that then is those bits filled in. So now it's a matter of filling into our formula, which is V1 M1 over N1 equals V2 M2 over N2. So then fill in, it's just substitution. So 21.6 times 0.1 over 2 equals 25 times X times 1. Now we want to make this the subject of the formula. So the handiest thing to do here is to cross multiply. And that will give us 2 by 25 by X. So that's basically going this to the bottom here by the top here, and the top here by the bottom here. And that will equal 21.6 by 0.1 times 1. Now we're isolating X, so divide across by 2 times 25, which is 50. Right over here by 2 times 25, and that then will cancel those two guys, and we'll leave us with x here, and then if we work that out, 21.6 times 0.1 times 1, and divide that by 50, so we get 0.0432. Okay, so that's moles of Na2CO3 by XH2O. Now remember, that's moles per litre of that. It then goes on in the question to, I probably asked this for the grams per litre. So that's the answer to part 1. Part 2 then, grams per litre. Remember this formula, mass number of moles times molecular mass. So let's put it off there now. We want to get the mass. So the mass equals the number of moles times the molecular mass. So the number of moles here is 0.0432, and molecular mass is just for the, go back up. It's just sodium carbonate. Okay, actually I shouldn't put in the hydrated part of this. So it's just sodium carbonate. So multiplied by the molecular mass of this stuff here. So it's 2 times Na plus C plus 3 times O. So that's 2 times 23 plus 12 plus 3 times 16. And I think if you work that out, you get 106 grams from memory. That's 106 grams. So then it's 0.0432, multiply that by 106, and we get 4.5792 grams. Okay, so that's the first part of that done. That's part E, isn't it? So then it goes on to part F. Now part F asks us to do a couple of things. So this is the trickier part of this calculation. So calculate the percentage of water of crystallization in the crystals and the value of X, the average number of water molecules in the formula Na2CO3 times XH2O. Okay, so remember back here, we were told that we started off with 2.5 grams of this sodium carbonate with a certain amount of water in it. And then we end up with a mass here of 4.5792 grams per litre, and that's of Na2CO3. Now the key thing here is that mass of the Na2CO3 is in a litre of solution. Remember, we only had 250 centimeters cubed. So when you're looking at scaling this down, you have to divide it by a factor of 4 to give you to give you the mass that was present in the volumetric flask within the question. So you have to take the 4.57, actually I'll do it over here. So 4.5792 and divide that by 4. So 4.5792 divided by 4 gives us 1.1448. So we'll just say 1.15 grams, okay, of sodium carbonate present. Now, in the question, they tell you that there are 2.5 grams. That's what they dissolved in the volumetric flask. So that's Na2CO3 times XH2O. So we're saying that there's 1.15 grams of pure sodium carbonate, but they actually weighed out 2.5 grams of hydrated sodium carbonate. Okay. Now the question is asking you here the percentage of water of crystallization present. So we know that in total Na2CO3 with the water of crystallization in it is 2.5 grams, and there's the pure Na2CO3 is 1.15 grams. So if I say 2.5 grams minus 1.15 grams, that gives me, 2.5 minus 1.15, should be able to do it in my head, for sure. Let's use our calculator. So it's 1.35 grams of water of crystallization. So in other words, that is 1.35 grams. So of the 2.5 grams that they weighed out, 1.35 grams of it was the water crystallization. So get that as a percentage, divided across by 2.5 grams, multiplied by 100, and so divide that by 2.5 equals multiplied by 100. So we get 54%. So what we're saying is that 54% of this 2.5 grams that were weighed out was made up of just water. Okay? And the last part of the question then is calculating this X. So what is the number of moles of H2O in the Na2CO3 times X2O? So the handiest way to do this is to look at your 2.5 grams that was initially weighed out. So 2.5 grams, okay, that, remember, was in 250 centimeters cubed. That 2.5 grams relates to a certain concentration or a certain amount of moles, right? If we go back up, we worked out in the first part of our question the number of moles, you'll see it here, of Na2CO3. Okay? Now, for the solution we had, when we worked out our concentration again, it tells us that the concentration is 0.0432. Okay? So, 0.0432 moles per liter. However, we only had 250 centimeters cubed, so the concentration in the 2.5 grams, 0.0432 divided by 4, is actually 0.0108. Sorry, 0.0108. So that's in 250 centimeters cubed. So we can say now is that the 250 centimeters cubed, in the 250 centimeters cubed, the 2.5 grams equates to a concentration of 0.0108 moles. I want to calculate 1 mole. So in other words, calculate 1 mole, divide across by 0.0108, divide here by 0.0108, and that will give me 2.5 divided by 0.0108. I get 231.5. So 231.5. So this value is important. This tells us that 1 mole of Na2CO3 times XH2O, that has a mass of 231.5 grams. Now, we know that the mass of the Na2CO3 is 106 grams. And we know that water, I should add this on. We know that water has a mass of 18, 2 hydrogens and oxygens, so it's 2 ones plus 16. So it's 18 times X, or 18X. That equals a mass of 231.5. Bring over the 106, so I get 18X equals to 231.5 minus 106. And if I want to get X, divide by 18, so I get X equals, so it's 231.5 minus 106 equals divided by 18, and we get 6.97. So you round it off the nearest whole number, so in this case it will be 7. So in other words, our formula is Na2CO3 times 7 H2O. Okay? All of these questions are done the same. Alright, so once you know how to do one, they don't deviate from this kind of process. So any exam paper question or any question you come across in the textbook based on these will all be done the same way. Okay? Have a look at that question and how I've done it with the solution. And if you have any issues with it, please get on to me and I'll try and explain it for you. Okay? Thank you. Bye-bye.